Okay, good morning. This is April 29th. April 29th or April 30th? What is it? 29th. 2019. This is your 9 on a Monday morning. It's nice and dark and your brains are just waking up. That's great. So we have 9 questions that are outcomes that you have learned so far this year. The first question gives you a cube that is 40% full and asks you to calculate the volume. So the first thing you need to write down is the formula for volume. And since we already talked about the volume of any right prism is the area of the base times the height of the prism. What you need to do for this is you need to say, what kind of base does this have? Well, it's a square, so therefore it's side squared. And the height will simply be h. And since it's a cube, we know that all three of those heights are going to, or all three of those dimensions are going to be 5. So we're going to substitute 5 squared times 5. So you get 1 point for writing down the formula, and you get 1 point for substituting correctly. You get 1 point for simplifying correctly, and you get 1 point for writing the correct full volume, which is 125. So far, that's 4 points. But the last thing you need to do is calculate 40% of 125. And since 40% is 40 out of 100, or 4 out of 10, or 4/10, and of means multiplication, then the process you can actually use to solve this would be decimal 4 times 125. Grab your calculator and go decimal 4 or 40% of 125, and it tells you it's 50. So therefore, since 1 centimeter cubed of space equals 1 milliliter, therefore there are 50 milliliters in that container. So you would also get 1 point for writing this out and probably having that and probably having that. So use your best discretion for work. We're going to make this worth 4 points for here, and we'll mark it 3 points here for work to show partial volume. Now they might have done 10%. 10% of 125 is 12.5, and therefore 40% is 4 times that. But either way, they're going to have the answer, regardless if they use multiplication of a decimal or mental math with 10%. The goal is to show that you understand how to get partial volumes. Question 2 is a fraction operation, 1 3/5 plus 1 1/2. This is not a grade 8 question. This is actually a grade 7 question. And back in grade 7, you learned to change your mixed fractions into improper fractions. Once you have it there, find your common denominator and make equivalent fractions. Of course, 8/5 is equivalent to 16/10, and 3/2 is equal to 15/10. Once you have your common denominator, you have 16/10 plus 15/10. You would add your numerators, keep your denominator. How many tenths do you have in total? You would have 31/10, which is improper. Change it back to mixed, and you would have 3 1/10. However, alternatively, they might have done this. Since it is addition, they might have added 1 and 1 to get 2, and then taken 3/5 plus 1/2 and repeated the process for just the fraction parts. 6/5 plus 5/10 is 1 and 1/10. Add it onto here, would still be 3 and 1/10. Okay, so we'll make this one worth 4 points. 1 point for showing either the equivalent improper fractions, or 1 point for showing how they broke it down. 1 point for equivalent fractions with the same denominator. 1 point for adding the numerators to get 31/10, and 1 point for reconfiguring it as that. So this question would be worth 4 points. Question 3, you have 1 3/5 times 1 1/2. Again, same fractions, different operation. This is a grade 8 question, but the process will be the same. We're going to change both of these into improper fractions. And I'm going to copy this because there are 2 processes they might have done. The first thing they might have done is they might have simply multiplied the numerators to get 24, multiplied the denominators to get 10, got 2 and 4/10, which would be in lowest terms 2 and 2/5. If they might have done this, they might have said, well, I know that when I multiply fractions, I can cross-reduce. They might have got 4/1, which means when they multiplied it out, they got 12/5, which would be 2 and 2/5, the same as the other answer. Question 4 gives you an algebra question. It says a negative third of a number plus 2 equals 1.5. So again, this is all process driven. You remember that this is your constant, your plus or minus value, and your coefficient is negative a third. Don't forget, just as a point of reference, that this fraction is the same thing as this fraction, which is the same thing as a negative third of x. You don't really need to know that for this question, but just as a point of reference so you remember what it really means. It does mean those things, okay? So when you have these questions, you realize that you were told that the easiest way to isolate the variable is to get rid of the constant first, and we use opposite operation. So the first thing you probably see on your paper is to subtract 2 on both sides, forming a 0 pair, leaving you with just that negative third of x on one side. And now we have a very difficult kind of question to think about. I have 1 and a half. I'm going to make a half there. And you have negative 2. Well, these two are going to make a 0 pair. And this are going to make a 0 pair with a negative half left over. So if you have $1.50 and you owe $2, you really just owe 50 cents because they take your $1.50 from you and you just owe 50 cents more. You're going to multiply both sides by negative 3. And 50 cents times 3 is $1.50, which is 1.5. And a negative multiplied by a negative will give you a positive. So your answer is positive 1.5. Your next question comes from your chapter on linear relations, and it says graphing linear relations. So when we have a straight line on a table, on a graph, we know that there is an equation, an algebraic equation that can be used to represent the value between the x-coordinate and the y-coordinate. And of course, the first thing you should do is draw your table of values to match the 3 ordered pairs that are here. This is 120, 1 on your x, 20 on your y. This is 223, 2 on your x and 23 on your y. And this is 3 and 26. Those 3 points can be put into a table of values. And once you have your table of values, you can find your coefficient by finding the difference. So I'm going to put x equals y. The difference here is 3. The difference here is 1. And 3 divided by 1 is 3. And that tells you the coefficient of your equation. Once you know that, you take any ordered pair you want. I'm going to start with 120. And you put your x as 1 and your y is 20. And since 3 does not equal 20, you require a constant of plus 17. And you have solved the equation that matches all of the points in that line. And you can write that right on the line. 3x plus 17 equals y is the equation that matches that line. Question 6 says 5 pencils cost $1.20. How much for 12? Solve 2 different ways. So of course, the 2 ways that we learned when we studied this ratio, rate, and proportional reasoning is that we could say the cost per pencil, and we could set it up as $1.20 for 5 pencils. And what we really want to do is the first thing we do is we want to say, well, how much was 1 pencil? If 5 of them was $1.20. And we would find out that each pencil was 24 cents. And if 1 pencil was 24 cents, then 12 pencils would be 24 cents each, multiplied by the 12 pencils I'm buying. 24 pencils would be $2.88. This method, if you'll remember, is called your unit rate. Finding out how much 1 costs and then finding how much 12 costs. Find the unit rate for the cost. That's method 1. Method 2 is to use proportional reasoning. And you would set it up using a proportion. So $1.20 for 5 is proportional to how much for 12. All right? And here we could solve it either by saying, well, what did I multiply 5 by to get 12? Which we don't know. But the easier way we learned was to cross-multiply to create an algebraic equation. So 5x equals the product of $1.20 and 12, which should be $14.40, but I'll double check. $1.20 multiplied by 12 is $14.40, or 14.4. Divide both sides by 5, and 14.4 divided by 5 is 288. Your next question says, what is the distance from A to B? And it doesn't explicitly say to use Pythagoras, but the only way to calculate that dotted line is to use Pythagoras. So you would redraw this as a right triangle. Excuse me, right triangle. Bring this over here. This would be 10, this would be 8, and the hypotenuse would be x. So probably they drew squares onto the sides and they put 64 in here and 100 in here, and they put 164 in here. So what is the distance from A to B? The distance of AB is the square root of 164, which is approximately, if I grab my calculator and square root it, 12.8. Okay. However, they might not have drawn squares. They might have said, well, I know that A squared plus B squared equals C squared. And they might have said, well, legs are the two sides that make up the 90-degree angle, and my C is my hypotenuse. So 8 squared plus 10 squared equals x squared, or 64 plus 100 equals x squared, or 164 equals x squared. And they simply would have square rooted both sides. Square root of x squared is x, and the square root of 164 is 12.8, approximately. So therefore, the distance between A and B is approximately 12.8. Your next question is an integer question, and it's actually a bedmass question. So here we have a good example of brackets. Now I use square brackets, but I didn't need to. And that means do this first, because if the brackets weren't there, and if I took my eraser and I erased this bracket and I erased this bracket, I would not do 10 take away 15 first. I would do 3 take away 2 first. But because the brackets are there, I'm going to do this first. And 10 take away 15 is not 5. It's negative 5. So when I simplify the brackets first, I get negative 5 plus the product of negative 3 and positive 2, excuse me. My next line would be solving or simplifying the multiplication, which would be negative 6. And 5 negatives plus 6 negatives is 11 negatives. And your last question gives you a cylinder and says, what is the surface area? Now, there are two ways you could solve it. The first way is to draw your net and to realize this is pi r squared. And to simplify 3 probably for pi, because we've been doing it all year. You might use 3.14, but without 3.14, you can use it in your head. 3 times 16 would make each of these circles 48 centimeters squared. So I could put it right in the net. And this one, remember this distance here is really the same as the circumference of the circle that it attaches to it. And since circumference is pi d, that's going to be that length. And this distance here is really the height of the entire prism itself, which is h. So instead of doing length times width for that rectangle in my net, we learned that we do pi d h, or pi times diameter times h. 3 multiplied by the diameter. If the radius is 4, then the diameter is 8, and the height is 10. 24 times 10 will be 240. So inside your net, you will have the surface area of that as being 240. And then you'd add them together. 4, 4, 4 is 12, plus 1 is 13. So therefore, your surface area, according to the net, if you did it each separately, would be 336. Alternatively, there are people who realize that the same thing can be accomplished by simply writing it out as a one bed mass question or order of operations. The two circles is this part of the formula, and the rectangle is the pi dh part. Substitute 2 pi r squared plus pi d h. And again, this part here is right here. This part here is really here, but times 2. That's what the coefficient does. So when we simplify it, we'll end up with 2 times 3 times 16, which I think we did already, didn't we? Is 96. And 3 times 8 times 10 is 240. And when we add those together, we still get the same surface area. So either way you did it, either with a net, you got 336, or with a formula, you got 336.